Hello friends, welcome to my channel Swapnil Facts Education and Art and Craft. Today we are going to learn about rational numbers. This is number system part 11. So without any further ado, let's get started. So first, what is rational numbers? Numbers which can be represented in p by q form where p and q are integers and q is not equal to 0 is called a rational number. So rational numbers are represented in p by q form. P and q are integers, that is p and q should be integers and q cannot be 0. We have seen in integers that integers include negative numbers, positive numbers and 0 also, but q cannot be 0. P can be any integer but q cannot be 0. Other than 0 it can be any integer. Okay, so let's see some examples. And yes, remember that the GCD, that is the HCF of p and q, should be 1. Although here we can reduce the fractions to get like this minus 5.32, we can reduce it to simplest form and get in the p by q form. But their GCD, if it is other than 1, we use that to prove irrationality of irrational numbers. That is why they are irrational. So let's see some examples. Minus 1 by 4, p is minus 1, q is 4. 1.91. You might be wondering, this is a decimal. How is this a rational number? So 1.91, as I have taught you, that the number of places it shifts in the numerator, the same number of places it shifts in the denominator. So 1.91, 2 places to the right, and in the denominator that is 1, 2 places to the right, so 191 by 100. So p is 191, q is 100. Now 5 by minus 8, p is 5, q is minus 8, 1 by 10, p is 1, q is 10, minus 3 by minus 4, p is minus 3, q is minus 4, minus 5.32, as I have told, these 2 decimal places to the right, denominator will be 100 as 2 decimal places to the right, there, so minus 532 by 100. So 532, that is minus 532 equals p and q is 100. Now, you might be wondering how integers are rational numbers, right? So let's take an example, minus 2. So as we have known that minus 2 divided by 1, as denominator has nothing, so it is 1 and q can be 1. It is not written in the condition that q cannot be 1. Q cannot be 0, but it can be 1. So integers are rational numbers, that is p is minus 2 and q is 1. Now what about 0? 0 by any number, that is any integer, is a rational number. 0 by minus 1, 0 by minus 100, 0 by 10, 0 by 36. 0 by any number you get is 0. So it is a rational number. But 0 by 0 is indeterminate and q cannot be 0, as I have told you. Now let's learn how do we plot rational numbers on the number line. So 3 by 4. As it is a proper fraction, take the region between 0 and 1, divide it into 4 parts and select the third part. So first, second, third. So this is 3 by 4. Now minus 5 by 8. Minus 5 by 8, ignoring this minus sign, so it becomes 5 by 8. As it is a proper fraction, so it will lie between 0 and minus 1 because of the negative sign. So divide the region between 0 and minus 1 into 8 equal parts and plot the fifth part. First, second, third, fourth, fifth. So this. I have seen many people doing like this, that is first, second, third, fourth, fifth. So this is minus 5 by 8, they say. But it is actually not. Because you have to always plot, that is count from 0. That is from the right hand side and not from the left hand side. Remember this point. Now minus 7 by 4. When we convert minus 7 by 4 to mixed fraction, we get minus 1, 3 by 4. So it will lie between minus 1 and minus 2. So divide the region between minus 1 and minus 2 into 4 equal parts and plot the third part. So this is minus 7 by 4 or minus 1, 3 by 4. Now 7 by 8, as it is a proper fraction, it will lie between 0 and 1. Divide it into 8 regions and select the seventh part. First, second, third, fourth, fifth, sixth, seventh. So this is 7 by 8. Now let's see addition of rational numbers. So how do you add rational numbers? You add rational numbers just like fractions. This is the reason why I have taught you fractions before rational numbers, because if you are okay with fractions and the addition of fractions and also decimals, that is addition of decimals or any operations on fractions and decimals, then it would be easy for you to do the operations on rational numbers. So let's see. 2 by 3 plus 5 by 4. This is an example. So first take the LCM of 3 and 4. So 4 comma 3 is 12. LCM of 4 and 3. Or as it is co-prime, so you can simply take the product. So 4 into 3 is 12. Now 3 into 4 and 2 into 4. So 4 2 is 8. 8 by and 3 4 is 12. So 8 by 12. 5 into 3 by 4 into 3. So 5 3 is 15 and 4 3 is 12. So 15 by 12. So 8 by 12 plus 15 by 12. You get is 23 by 12. Now, how do you subtract rational numbers? So, let's take an example. Minus 5 by 9 and minus 3 by 5. This minus minus will be cancelled to plus, because plus into plus is plus. Plus into minus is minus. Minus into plus is minus. Minus into minus is plus. So, minus minus goes to plus. Minus 5 by 9 plus 3 by 5. Now, the LCM of 9 and 5 is 45. So, 9 5s are 45 and 5 5s are 25. So, minus 25 by 45 plus 5 9s are 45 and 9 3s are 27. So, 27 by 45 minus 25 by 45 plus 27 by 45. Simply add these numerators. You get 2 by 45. Now, multiplication of rational numbers. Minus 4 by 6 into 2 by 3. How do you multiply rational numbers? So, you do simply like fractions, keeping this minus in hand. So, ignoring this minus sign, cancel this 4 and 6. 4 goes with 6, that is 2 by 3. And because of the minus sign, so it is minus 2 by 3 into 2 by 3. So, minus 2 into 2 by 3 into 3. You get minus 2 into 2 equals minus 4 and 3 into 3 is 9. So, minus 4 by 9. So, minus 4 by 6 into 2 by 3, you get minus 4 by 9. Now, let's see division of rational numbers. Let's take an example, minus 7 by 8 divided by minus 3 by 6. So, minus 7 by 8, keep it as it is. Change this division sign into multiplication sign. The moment you do it, take the reciprocal of the other number. So, minus 7 by 8, changed this division sign into multiplication sign, and the reciprocal of minus 3 by 6 is minus 6 by 3, because when you multiply them, you get 1. Now, then as usual, you can do with the normal multiplication you do. So, 8 goes with 6 with 8 goes with 6 with 2. So, 4 and this minus 3. And minus 3 by 3 you get minus 1. So, minus 7 into minus 1 by 4. Minus minus gets cancelled. So, 7 into 1 by 4, that is 7 by 4. This is how you divide rational numbers. Now, let's see the properties of rational numbers. First, closure property. Closure property for addition. Let's take an example. Minus 3 by 2 plus 1 by 2. When you add them, you get minus 1. You get a rational number. So, addition is closed. Now, multiplication. So, minus 3 by 2 into 1 by 2. You get minus 3 by 4. So, multiplication is closed for rational numbers. Now, subtraction. Minus 3 by 2 minus 1 by 2. You get minus 2. So, subtraction is also closed. That is, when you add, multiply or subtract, you get a rational number only. Now, what about division? Let's see, minus 3 by 2 divided by 1 by 2. So, it is minus 3. So, division is closed under rational numbers. But no, it is not closed because of one small caveat. That is, if you have picked minus 3 by 2 and 0. So, minus 3 by 2 divided by 0, is it defined? No, it is not defined. So, division of rational numbers is not closed. Minus 3 by 2 divided by 0 is undefined. So, division of rational numbers is not closed. Now, commutative property. So, commutative property, as you know, that a plus b equals b plus a, like that. Now, commutative. For addition, minus 3 by 2 plus 1 by 2, you get minus 1. and 1 by 2 plus minus 3 by 2, you get minus 1. So addition is commutative. What about subtraction? Minus 3 by 2 minus 1 by 2, you get minus 2, and 1 by 2 minus of minus 3 by 2, you get 4. So is minus 2 equal to 4? No. So subtraction is not commutative. What about multiplication then? Let's see an example. Minus 3 by 2 into 1 by 2, you get minus 3 by 4. 1 by 2 into minus 3 by 2, you get minus 3 by 4. So multiplication is commutative, as minus 3 by 2 into 1 by 2 equals 1 by 2 into minus 3 by 2. Now division. Let's take an example. Minus 3 by 2 divided by 1 by 2, you get minus 3. But 1 by 2 divided by minus 3 by 2, you get 1 by minus 3. So as you can see, minus 3 is not equal to 1 by minus 3. So that is division is not commutative. Now associative property, you know, that is A plus B whole plus C equals A plus whole B plus C. So A plus B plus C would be in bracket. I have taught you in the chapter of whole numbers. Now let's say associative property. First, addition. So minus 3 by 2 plus 1 by 2 whole. So first add them, you get minus 1, and then take plus 1. So minus 1 plus 1, you get 0. Now minus 3 by 2 plus in bracket 1 by 2 plus 1. So if you add 1 by 2 plus 1 first, you get 3 by 2, and 3 by 2 plus minus 3 by 2, you get 0. So addition is associative. Now let's see about subtraction. Minus 3 by 2 minus of 1 by 2, you get minus 1. No, sorry, minus 2. And minus 2 minus 1, you get minus 3. And if you do 1 by 2 minus 1 first, you get minus 1 by 2, and then minus 3 by 2 minus of minus 1 by 2, you get minus 1. So minus 3 is not equal to minus 1. So subtraction is not associative. Now what about multiplication? Minus 3 by 2 into 1 by 2. Multiply them first. You get minus 3 by 4. Then multiply 1. You get minus 3 by 4. And then minus 3 by 2 into 1 by 2 into 1. So 1 by 2 into 1. Multiply them first. You get 1 by 2. Minus 3 by 2 into 1 by 2. You get minus 3 by 4. Now let's see about division. Minus 3 by 2 divided by 1 by 2, you get minus 3. And if you divide it by 1 by 2, you get minus 6. And if you divide 1 by 2 divided by 1 by 2, you get 1. And minus 3 by 2 divided by 1, you get minus 3 by 2. Is 6 equal to minus 3 by 2? No. So division is not associative for rational numbers. And you know the distributive property, that is A into B plus C equals A into B plus A into C, and A into B minus C is A into B minus A into C. I think you know the distributive property of rational numbers. It is true for all numbers actually. So here we come to the end of the topic rational numbers. This is all for today. Thanks for watching. Please like, share and subscribe to my channel. Thank you.